Hey guys, welcome back. In this video, we're going to be looking at grenades and some other sort of lobbed projectile kind of actors, that kind of thing. And this particular one we're going to make is a flashbang grenade, similar to what you would see in Counter-Strike. We're going to white out the screen when it goes off. We're going to add a little explosion decal, and obviously the lobbed projectile itself, which is just this static mesh here, which is fairly simple, fairly basic, and this explosion decal, which you can pick up in a link in the description, both the mesh and this texture. And that's all you're going to need to get started. So first of all, let's make our decal material. So just right click, and we'll just call this one explosion decal matte. Just like that, and we'll open it up. Easy enough so far. We'll drop in our explosion decal. Let's make this one full screen so that we can see it. And then over here on the right, we'll change our material domain to deferred decal. Yeah, we'll just ignore this because we'll set it to translucent in the blend mode. And then in our decal blend mode, we're going to change it to debuffer, translucent, color, and roughness. And that's all we need to get started. So let's just make it constant, set it to, oh, where we go? Set it to 1, and this will just set our roughness as rough as possible. Our base color is a 3 vector, just hold in 3 and click, and we'll leave it black. Plug it into base color, and then the opacity from our decal texture go into opacity. And that's really it. So we can see it over here. In fact, we set it to a plane, this preview mesh, and we can see it on a flat surface, just like this. So with that out of the way, let's just hit save, and then head back to the editor, and we'll do the next thing. As I fill words while this material finishes saving. There we go. All right, the next thing, and this might be slightly controversial, is that the way that I'm going to do the flash effect is in post-processing. So if we make a new material, call it flash pp, and then we'll open that one up. Let's start with, well, let's get our scene texture node. Scene texture, and we'll change it to post-process input 0. And we're also going to need to mask this out because this type of effect, it won't work with alpha. So just come out of here from the color and find a component mask, and just enable all of these little boxes except for the A. We don't want the alpha value, otherwise it won't compile and the effect won't work. Out of this, we'll hold an L and click for a lerp, make this our B value, make a new 3 vector, right click this, convert to parameter, call it the flash color. And for the sake of just a flashbang effect, we're going to make it solid block white. And this will make our A value. Alright, as for the alpha, let's just hit save on this for the time being. And then we'll head back to the editor and make ourselves a material parameter collection. So right click, go to materials and textures, find material parameter collection, and we'll call this one flash params. Open it up, and here we have some elements that we can add. So we just need a scalar. So just hit a little plus, bring this down, and we'll call it the flash value. Flash value defaulted at 0, hit save, then back in our flash post-process material, just right click, type in collection, we need a collection parameter, this one from our flash params, and make it the flash value. Plug this into the alpha, and then the lerp into, where are we? Well, it goes into emissive. There's an error there, that's only because we need to set our material domain to post-process. There we go, so that's all good, it's all well and done, and we're ready to continue. So hit save, and let's start building out our flashbang. Alrighty, so let's right click, go to blueprint class, make ourselves a new actor. We'll call it the flashbang. Where are we? Flashbang underscore BP, because we're going to use the player to spawn the flashbang, and then the flashbang itself is going to, you know, lob from the player, which is simple enough to get started. Let's add a component, make it a static mesh, and over here we want to enable physics. So where are we? Where's physics? Simulate physics. Why can't we simulate physics? Right, we need to set up our collision. So in this collision presets here, bring this down. We want to find where are we? Physics actor, and then we'll compile. Oh, and we should declare our static mesh. So up here in the static mesh, we'll find our flashbang mesh, add that in. That's simple enough. And then we can click on this box to simulate physics. We'll get our mass in kilos, set this up to something fairly high. Let's say 2000. You compile and save. And we'll also check the size. So drag it into the world, and yeah, our flashbang is way too big. So back in the flashbang BP, let's get our mesh selected. We'll come up here to scale, and we'll make it something like 0.2. That should be big enough. Compile, and yeah, that's a bit more grenade sized. So we're ready to move on now. So back in the flashbang, and actually we'll just we'll delete this guy from the scene. Back in our flashbang blueprint, let's go to the event graph. Now we need to delete these two because we'll just go off the begin play. And when the flashbang is spawned by the player, it's going to generate all of its physics information on its own. It's going to lob itself through the map. So straight out of this begin play, let's just cast to our first person character because we're using the first person character for this. We'll get the player pawn as our object. There we go. And then we can do our physics calculations. Let's grab our camera from our first person character. So let's just get first person camera and also the forward vector. So we know which direction the first person player's camera is pointing. And we'll multiply this value by our multiply value. So we can control how much the distance that the grenade is lobbed by manipulating this value. For the time being, we'll just hard code it at 1500. And then out of our cast to the first person character, we're going to add impulse to the static mesh. So this is going to it's going to add our physics information. It's going to add that, well, impulse, a physics impulse to the static mesh. So plug in our result of this multiply into our impulse. We'll hit velocity change, and then we're about ready to keep going. So the second thing we'll do after adding just the initial lob is some rotational physics that it kind of spins and tumbles through the air. And to do that, we'll just come out of this add impulse with an add angular impulse in, let's use degrees. We'll plug in the target to our static mesh so that we're applying it to the same object. And then, where do we get our, all right, so we don't need the forward direction for angular impulse. We just need some, just a value. Let's right click, we'll get a random unit vector. Just like that, and we'll multiply it by another value, vector multiplied by float, and this will be the amount of rotation. It's going to generate a random unit vector, multiply it by this amount, so that we get some good tumble and some good randomness in our throw. So we'll set this to something like 350, something fairly high. Plug this into impulse. We'll also set this velocity change here, and then out of this add angular impulse, we need a delay. And this delay is going to act as our fuse time. This is the length of time that the grenade is going to spend before it eventually goes off. Let's say 3 seconds. 3 seconds is perfectly fine. And then we will spawn our decal. So just compile and save that for the time being. And then back in the editor, let's right click here. We'll make ourselves a new blueprint. Make it an actor. This will be our decal, or let's call it the explosion decal BP. And we'll open that one up. Add component. We want to add our decal to this component. And where are we? We want our decal material to be the explosion decal matte. Perfect. So then here in the blueprint, we want to change some of these values over here, particularly in this decal tab, just to adjust the size and shape that our decal is going to appear in the world. So set our X here to something pretty low. Let's go 9. So it's going to be quite thin. And what else do we want to change? We want our fade start delay at 4 seconds. So it's going to spend 4 seconds in the world before it starts to fade out, and our fade duration at 2 seconds. Fairly self-explanatory, and this should be all that we need to do with our decal. So compile and save, and then we'll head back to our flashbang blueprint, and we'll come out of this delay here, our fuse time, and spawn the decal as an actor. So spawn actor from class. Class is going to be our explosion decal. And we'll split this transform pin here so that we have some more control, some more sort of access to these values here. And we'll get our actor location. This is the location of the flashbang grenade. And this will be plugged into location. And then if we come back here to our cast, to our first person character, we need to get the distance 2. So this will get the distance. In fact, this wants to be in other actor. So we want the distance between our flashbang and the player. And we'll be using this a little later to control, or to control our flash amount based on distance from where the grenade goes off. In the meantime, we're about ready with our explosion here. So hit compile and save on that. Then come back to the editor. We need to find our first person character, and we'll open that up, and we can build out our character blueprint, which is basically just finding a key. So if we type G key, get G for grenade, similar to Counter-Strike, and when we press it, we're going to spawn our grenade. So the first thing we need to do there, if we let's go to the viewport, we'll add a new component, just a scene component. We're going to call it our grenade lock, our grenade location. And this scene component, we'll put it somewhere up ahead of the player. So this is where the grenade is going to start. This is where we're going to throw it from. If you're handling animations and that kind of thing, this will be the moment where the hand of your player, releases the grenade. So hit compile, then back in the event graph. Once we've pressed G, we'll spawn the grenade. Spawn actor. Spawn actor from class. There it is. We'll split this transform again, and then we'll get our grenade location. We'll just drag this in, and then out of this pin, we can get the world location. Oh, I can spell today. Location. Oh. And then our world location goes into the transform location. So this will spawn our grenade. And now if we... Oh, what have I missed? We didn't declare the class. So we need to make sure that our spawn actor has the flashbang blueprint plugged into it. All good, all done. Let's hit save. And then we'll go back into the editor and hit play. And now we're in the world with our first person character. If we hit G, we're throwing our grenade around. Very, very cool. So this is the basic functionality for the grenade. It's not going to destroy itself or anything, but we're getting different rotations each time, and it's going to lob through the world and spin at different rates with each time we throw the grenade. Now there are a few things we have to do. For one is make sure that the grenade destroys itself once it's finished, and also the actual flash effect. So let's just save all and we'll continue on. So actually, before we continue, so we'll go back into our game here. We'll hit G to spawn the flashbang, and we'll notice that it's not spawning the decal. I just added a quick little print screen to make sure that we're not failing at this node, but it is not spawning the decal in the right place. So in order to fix that, let's come out of our static mesh component here. We'll get the world location. Where are we? Oh my god, if I can spell today. Get world location. And replace our get world location with this spawn transform location here. So we'll compile that, we'll hit play, and then back in the game here, we'll wait for the 3 seconds, and there it's spawning the decal, but it's spawning it with the wrong rotation. So to correct that in the spawn transform rotation here, set our Y value just to 90, just to rotate it around, so that once we throw the grenade, it's going to spawn the decal properly. Now it's going to hit these vertical surfaces as well, which we can fix by just making the decal a lot more thin, a lot slimmer. In fact, we could change these values to make it smaller. I'm not going to worry about it for the time being. But now that we're spawning the decal in the right place, we can let's come out of here just into a destroy actor, so that the grenade is being destroyed once it's spawned its decal, just to make a little bit more sense in the world. And while we're here, let's crank up the weight, our mass in kilos. We'll set this up to like 5,000, just to make it a little less bouncy. And then back in the world, it's still kind of bouncing around, but we can adjust these figures sort of whenever we want. But as we can see now, the grenade is landing, spawning the decal after the 3 seconds. And then if we wait here and watch, the decal is going to spend a few seconds around, and then it's going to fade out. All right, so that's all working as normal. Now we can control the fade effect. And to do that, we'll come back to our first person character here, and we need to make ourselves a custom event. So just right click, make a custom event, and we're going to call it Flashbang. Just like that. And we can, well, let's compile it first. We need a couple of inputs. Most notably, what we need is the distance. So we'll make a new input, call it distance. It's going to be a float. And another parameter, we'll call it the facing angle. facing angle. So this, with these, and this will be a vector. So with these two values, we're going to find the distance from the flashbang that the player is, and also the angle at which the player is facing the flashbang. All well and good. So let's make some calculations. Let's go back to our flashbang blueprint, and we can start playing with this get distance too. And we'll also come out of our cast here because we need to get our flashbang event. Easy enough. So we'll put the flashbang event just before the destroy actor. Plug all this in, and our distance will be out of this get distance 2, and then we'll just calculate our facing angle. And to start by finding our facing angle, we'll need the location of this actor. So let's get actor location and plug this into facing angle. So now with these values being fed into this event, we can grab them in the first person character out of these two inputs. So far so good. Let's just save all of this so that things should be working fine when we test them out. And then we can continue. So let's start with, well, we'll need a new variable. This will be our flash amount. And we're in the first person character. We need a flash amount. Need to set it to a float. And we'll compile that, save it, drag this in as a set. And this will be the first stop in our flashbang event. So what are we doing? So to get our flash amount, to calculate that, we need to play with this distance value coming out of the flashbang event. So we'll drag off that, make a normalized range, and this could be a tricky node to play with, tricky to get the values right. So for the time being, we're going to set our minimum to 20 and our maximum to 100, and that should get us a lot of the way there. And I got my notes here. So the next thing I did, we float divide by float. We're going to divide this value by 10. And then we're going to multiply it by -1. Where are we? Float multiplied by float, multiplied by -1. This inverts the values. Makes more sense in our flash amount. And the result of this multiply plugs into this set node. So far so good. So then out of this set, we'll make a branch. You can hold in B and click for a branch. And get the distance again out of this flashbang event. They need to find out the maximum value. So if the player is beyond a certain distance from the flashbang, then they shouldn't get any flash effect. So if they're beyond, let's say 2,000 units, we can plug in the condition there. And that way, only if the player is within that 2,000, we come out of this false node here, then the player will get flashed. Okay, so moving forward, we're going to need to find the angle from the flashbang that the player is facing next, so that we can tell, because if you're not facing the flash, then you're not going to get flashed, and if you are, then you will, and we'll get some range there. So we need a new function. We'll call it angle from flash, and then we can compile, and we'll build this out and make our checks here. So to get our angle, let's make our we'll make an input. It needs to be a vector. This was the grenade location. We'll just call it grenade lock. We'll compile that. And then come out of this grenade lock, we need to find the lookout rotation. So that the first person camera, which we'll drag in, we'll get our lookout rotation from the camera and use it to find, well, first of all, the get world location of the camera. Plug this in as our start value. The grenade location is our target value. And then we'll also need the rotation of the camera. So we'll drag up here, get world rotation. And we'll have to split this so that we get to play with, so that we can play with floats. Same with the find lookout rotation. And we'll subtract the Z value. Float minus float. Subtract the Z values from each other, because this is just the vertical rotation. If you imagine the camera on a pole, just moving around, just rotating on that single vertical axis. That's the only sort of angle that we really need. We'll subtract them both from each other and then check whether this value is greater than or equal to or less than and equal to 90 degrees. So greater than or equal to 90 or less than or equal to -90. So 0 will be directly ahead. 0 would be if we are looking directly at the flash, and then 90 degrees left and -90 is to the right, or vice versa. We'll get these checks. We'll grab out of this boolean into an OR, like that. And then we'll come out of this into the return node. So out of this, out of our function here, we need to get a return, add return node, and our output is this boolean. So we'll rename this to isFacing. Make sure we set it to a boolean. And we're done. So the result of this OR goes into the isFacing. We'll compile that. It compiles fine. Save. So this is how we calculate the angle at which the player is facing the flashbang. At the moment, we're only checking to see if we are within or without 90 degrees, but you can expand these values to sort of more finely tune the amount of flashbang that you get. This is just a single stage flash. So we'll come back to our event graph and then check our angle from flash. So we'll drag in our function, come out of the false of our branch into this, and then our grenade location is the facing angle of our flashbang event. All right, so far so good. I hope that makes sense. The next step is to make sure that the player is facing. So we'll come out of this angle from flash into a branch. And if they are, we can set our flash amount. We'll set our flash amount to 0.5 to half. Just like that. And if false, we'll set it to our current flash amount, which should be 0. So right click, set scalar parameter value. Plug this into here, and then our other scalar into false. So it looks like this. And then we want our flashbang params. Flash params, the parameter name is flash value. And then grab our flash amount, just get, and plug that into the scalar value. So I hope this makes sense so far. We'll come out of this parameter value just into a delay so that there is an amount of time that the player is going to spend flashed. We'll just make this 1 second for the time being. And then out of this delay, we'll make ourselves a timeline so that the flash value can fade out over time. So we can go from being flashed to fading back down, and all should be good. What's our flash amount? Yeah, we're setting our flash amount over here. Okay, good. Yep, everything's all lining up fine. In fact, let's move this, make ourselves a bit more space. Okay, here's our timeline. Now we're going to make a standard sort of looping float track here. What should we call this? We'll rename this. All right, we'll rename this float. And we want 2 values, 2 keys. Set our first key, time at 0, value at 1. Our second, wait a minute, that's not right. Value at 0. Time at 0, value at 0. And our second key, time at 1, and time at 1, value at 1. And then we want the length of our timeline to be 1 second. That's right, we don't want it to loop or autoplay or anything like that. So we'll compile, come back to our event graph, and now we have this little float value that we can play with. So we'll drag off here, find ourselves a lerp, float lerp. We want our float value from the timeline to be the alpha of this lerp. And we want B, let's go 1, and our flash amount, which we'll just get, will be A. So far so good. So we're going to go from 0 to 1, from the flash amount up to 1. And then when it's done, so come out of our timeline, set scalar parameter value. Same as before, we want the flash params, we want our flash value. And the result of this lerp goes into our parameter value just like that. Hit compile, and we should be about done with the flashbang event. So now if we come back to our editor, we'll hit play, and we'll see what happens when we throw a grenade. Alright, so nothing's really going on at the moment, so that's okay. We can do a tiny little bit of troubleshooting. Okay, so that was done. The reason that it's not working is that we haven't put the post process into our character yet. So come out here, the add component, find ourselves a post process, and we want to select that. Find our rendering features, post process materials, and add our flash material, just like you would in the actual world. So we compile on that. And we also need to revisit our flashbang blueprint because, yeah, we don't need to use this get actor location for our facing angle. What we need is the world location of the static mesh, which we used before to plug into the to correct the explosion decal. We compile on that, save, and we'll come back to the character. We'll just have a little bit of a recap here. So we're setting the flash amount based on the angle that the player is facing the flashbang, and we're also setting the amount based on the distance from the flashbang that that the player is looking at. Should be pretty straightforward from there. And we'll even go back to this flashbang blueprint, and we'll, not the blueprint, the decal. Where is our decal? Explosion decal. Okay, we can set this down to a little bit thinner. Let's go 7. We could also put some checks in to make sure that the decal doesn't render on vertical surfaces, but for the time being, for the purposes of the video, let's just click play. We'll hit G, and we'll see what happens. Boom. All right, so looking at the flashbang, the flash effect happens. If we look away from it, nothing. Okay, working perfectly so far. And we could probably, yeah, so even if we're looking sort of tangentially at the flashbang, it's still going to affect. So let's hit save on that, and that's about the end of the video, guys. So here's how to make, you know, basic sort of lobbed projectiles, which you could use not just for grenades, but for, you know, magic spells, that kind of thing, fireball lobbing, particle effects, anything that the player sort of lobs forwards. And just to make sure, let's throw a grenade, make sure that it's not happening when we're too far from it. So if we're further than 2,000 away, then the flashbang shouldn't show, just like that. Perfect. So there is a working flashbang blueprint for you guys. I hope you like this video, and I'll see you in the next one very soon. Cheers.